Hello. Yeah. I have no idea if you can see me or not. If I'm audible or not. Let me just check if this live is working or not, and then we can start. Yeah, it's not working. I think yes. So it's showing some error. Why doesn't it work properly from the beginning? But now it is working. Okay, yeah, so we are live. Hello. Hello, fellas. I'm really sorry. I'm doing live after a long time. So yeah, the setup took a lot of time. And yeah. Now we can get started. I do not know why it is showing offline in my OBS studio. So today is the most awaited video that you all have been waiting for. You all have asked me multiple times. Some of you have already appeared for your SATs, but some of you might be reappearing for it. And Desmos is now not only used for your SAT, but it is also used for your AP exam. So your AP pre-calculus, AP statistics, or AP calculus, you'll be using Desmos for nearly everything. So it has become even more important to learn about Desmos so that you can excel in your exams and you know the like not shortcuts, but you know the tricks, how to apply Desmos, how to use Desmos, what you can do with it and what you cannot do without it. So yeah, this is my long awaited video and I'm here with it today. I hope I'll be able to cover a lot of things because I have only 1 hour. So I think I'll be able to cover a lot of things in that 1 hour. Otherwise, we'll do part two of Desmos. So stay tuned and now I'm going to start. And if you're wondering what it is, so it's to keep my back straight. It's not straight even now, but it's to keep my back straight. So it's like posture corrector. Yeah. So without further delay, we'll start with the Desmos. We are over here. So first, I will just explain to you. So this is the version that you will be seeing for your digital PSAT, NMSQT, SAT, and AP version. So Desmos is a different version also, but here you'll be able to do these things. So now first, I will just explain what is everywhere. So you can see this plus sign. Here you can write any expression or any equation. And then you have a table over here. So you can write your table, and table is extremely helpful when you want to write an equation, when you want to, you know, do regression. And how to do regression? When you put over here, you'll be able to see regression over here. For example, let me write some values, some random values. Now yeah, when you click on it, like long click on it, you can see add regression. And over here, you have your multiple options. So this is very useful for your AP pre-calculus exam because there you're having your data modeling and you can directly apply linear regression, mx plus b, you're directly getting the equation and you can use the equation over here. Even if you don't use, you can see the equation is over here. And this is your red line. If you want quadratic regression, for quadratic regression, of course, you will need 3 points, but yes, you can do your quadratic regression, cubic regression, and then exponential regression. It's a times b to the power x. You can also do your logarithmic equation, a plus b ln x. Your power regression, that's not needed. Mostly you'll be needing your, sinusoidal regression also you can use. It's like this, a times b cx plus d plus this one. So this is what you can directly do, and this is the graph that you can see over here. Now sometimes what will happen, and now you can just zoom in over here. So your linear regression, quadratic regression, cubic regression, exponential regression, logarithmic regression, sinusoidal regression, you can do all of this. And now you can see there's a custom regression model in a new line using this particular key. So yeah, I have started with the regression, the topic I thought I would be dealing with at the end, but yes, I'm starting with that. So when you write the table, you can always do your regression. And regression means writing a model. So you can always make a model and do it. All right. So now, for example, sinusoidal regression is always giving you sine, and you cannot change it. But what if you want a cosine model? Then we'll be using a custom model. Okay. So how can I make a custom model? I will write y1. Why I'm writing y1? Because you have y1 over here. And then shift. So this key, this is, if we look at the keyboard, I don't know if you'll be able to look at the keyboard or not. Yeah. So over here, in your keyboard, you have 1, right? In every keyboard, you have 1. And before 1, there's a key. There are 2 symbols on it, this one and this one. So what you have to do, and there's a shift somewhat over here. So you have to press shift plus this key. This will give you this symbol. Okay. So press shift key along with the key before 1. I call it the key before 1. The first key on the numeric keypad. All right. So when you press these two together, you can get this symbol. And now, for example, if you want to use something different, for example, you want to use cosine function. So you can just write a cosine b x1 plus c plus d, or whatever equation you want to use. Now, one important thing to note is instead of y, we are using y1 because it's over here. Instead of x, we're using x1 because x1 is given over here. You cannot type x and y over here. Any other thing you can type over here. And now a, b, c, and d are your parameters. You want to find the values of those parameters. And instead of equal to sign, we are putting this particular symbol. How to get it? Shift and key before 1. I have shown it before. All right. For example, in sinusoidal regression also, it's not in a particular format. So you can also write it in this format. Got it? You can get the values. And now, for example, and you can do this for everything. I will. Okay, got it. Yeah. One more beautiful thing you have over here. Add regression. When you go here, you can see export as custom regression. You can see y1 is mx1 plus b. You can get the values of m and b. And now you can again export as custom regression. You can see y is ax1 squared plus bx1 plus c. This is for quadratic. All right. And so forth. So we have covered what can be done over here. You can write expression where you can write an equation. This is the table, and we have seen how you can do regression over here. And yeah, now next thing is your keys over here. So this is x, this is y. You can also just type from your keyboard This is a squared. So first you have to write any number and then you can do square like this. If you want to have some other part, for example, a to the power 10, so then you can just do a to the power 10. This is one way of doing it. How you can do it using keyboard. So for that, it's like this: 8, shift 6, and then you can write the power. So I'll show you how you can do it on your keyboard. Again, I'll annotate. Yeah. So again, you have your shift over here. And you will have your key where 6 will be written and on top of 6. So this particular symbol will be given. We are looking for this symbol because this takes you up to the exponent. So shift plus 6 takes you up so that you can write the exponent. I hope this makes sense. Okay. Yep. Now moving forward, you can type everything from here or you can just type from your keyboard. Everything is fine. You have division, multiplication, subtraction, addition. So how do we do? If you have a separate numeric keyboard, you don't need to use shift for that. But if you just have the top ones, then how can you do division? So it's one key before the other shift. Okay. That is how you do the division. For multiplication, there's a star symbol. For that, you do shift plus 8. So for multiplication, we're doing shift plus 8. Subtraction and addition, you can normally do. And I think for addition also, you'll have to use shift equals to. Equals to, you can directly put. This is your minus key. And 8. So if you do shift 8, you can see this is multiplication. All right. And decimal is just there. It's on the lowest key. Now square root you can take from here, but if you do not want to use this, you can just type SQRT. So SQRT is going to give you square root. From this you can get the absolute value equations. All right. Otherwise on your keyboard above enter you have to just do shift. So it's a key between backspace and enter. Over there you can see there's a pipe. So you can just press shift and that key and you can still get it. Otherwise you can get it from here. If you want any other letters, you can get everything from here. From A, B, C, D, this is factorial, this is subscript. You can do anything and everything from here. This is symbol given over here. So it's also given over here. Okay. Now you can go back to 1, 2, 3. So what I'm saying, either this is shift one key before one, or you can also get it from here for regressions. You can use the key function or you can simply type SQRT, you will get over here. Now pi, you can either choose it from here or you can just write pi. Greater than or equal to, write greater than symbol and then just write equal to. It will become greater than or equal to. So it's a combination of two keys. Now coming to functions. Trig functions, you can write sine, cosine, tangent, cosecant, secant, cot. You have all the functions, so you can also do the same thing. You can just write sine. And if I'm writing x, now you can see the graph. If I press home, you'll be able to see the graph. So this is the graph of sine function. For cosine, you can just type cos, and in parentheses, you can write your expression. For sec, you can do this, you will get a graph of secant. Cosecant, again, the same thing. This is tangent graph and this is cotangent graph. For cotangent, you type cot. So you can also use your keyboards or you can use functions from here. Now, apart from trig, you can also do inverse trig functions. So sine inverse, cosine inverse, tan inverse, cosecant inverse, secant inverse, cot inverse. You can get it from here. Or you can also type arc sine. That also gives you your sine inverse function. You can see it from here. And if I type sine shift 6 minus 1, x is the same thing. So either you can write arc. So arc sine, like arc in front of any trigonometric functions means the inverse. Okay? Yeah. And then you have statistics. So in statistics, you can find out mean. So in mean, you just have to write all the values separated by commas. You don't need to remember the formula or anything. It doesn't matter how many values are there, you will get your mean directly. Just remember, mean, inside parentheses, all your values should be separated by commas. This is how you can find mean. And one more important thing that you have over here. So here you can see, you can convert your decimals to fractions and fractions to decimals. For example, we have converted this to a fraction. If you click it again, it's a decimal. So it's a very good thing to convert from decimal to fractions. Okay. And then similarly, you can find median. So in median also you have to have, and for example, if you're doing median by yourself, you'll have to do what? You'll have to arrange them in order. Here it's not necessary. I can write them in any order. Again, they should be separated by commas. It will give you what the median is. So again, you can figure out the minimum value. So you just have to write min. Okay. And then again, you just have to write all the values. But for it is not needed because you can directly see what is the minimum value. 12 is the minimum value. So it's giving you the minimum. Similarly, you can get the maximum value. Now let's see how we can get quartile. So again, what it is saying, function quartile requires two arguments. For example, you have to write your values and then comma, you have to write which quartile you're looking for. So if nothing is giving you anything, you can just go to this error or warning sign and it will tell you what you have to do. Two arguments means you have to give two parameters. First one, you have to write your values, all the values inside square brackets, and comma, you have to tell which quartile you're looking for. First quartile, second quartile, third quartile. There are only 3 quartiles. So yeah, now we'll do that. For example, if you're looking for first quartile, it is 18. Second quartile is 56. Third quartile is 82.4. If you write 4, it's 89. 5 is undefined. 0 is 12. So 0 is 0th quartile means the minimum value. First quartile means the first quartile. Second quartile means the median. Third quartile means the third quartile. And fourth quartile means the greatest value. Okay. If you give any other value, it will give you undefined. Because it does not exist, you only have minimum, first quartile. So minimum is 0. First quartile is 1. Second quartile is, or median is 2. Third quartile is 3. And your maximum is 4. So this is how you can get your quartiles as well. I don't know what is quantile. We have never learned about it. So let's see what it is saying. Here also you have to give two arguments. And I think, but quantile, we're not going to use it, so I'm not going to explain it. Standard deviation. So if you want to calculate standard deviation, you just have to write STDEV. And again, you can just give the values. It's going to calculate the standard deviation for you. You don't have to do anything. This is standard deviation of the sample. If you want to calculate standard deviation of the population, then you have to do STDVEP. So this is standard deviation for population. Okay. So this is for AP statistics. So this is giving you standard deviation of the population, and before it was giving the standard deviation for sample. There's a difference in the formulas. This is giving you variance. Variance is square of standard deviation. So you can also calculate variance from here. And again, you can convert it into a fraction or a decimal. So you can type also. For example, if I just type VAR and it has become variance function. Then MAD is your mean absolute deviation. So you can also find mean absolute deviation. Okay. And again, you can convert back to a fraction. Covariance, correlation, Spearman rank coefficient, stats, count, total. You can do anything. So in count, let's say what's happening. So it'll give you the number of elements that you're typing. So that's very simple. Okay. So in deep statistics, I'm not going, but I'm showing you that you can find out everything from here. You can find correlation as well. So how to use correlation? It will tell you. So correlation must be list because you're going to find correlation between two data sets. For example, on x-axis and y-axis. So you just write whatever is going to be on your x-axis. And then you just write what is going to be on your y-axis. So this is going to give you what is the correlation between them. So it's a negative correlation and it's a strong one. In stats, let's see what they're saying. Okay, you just have to give a list. So yeah, it's giving you everything. What is minimum, what is first quartile, what is median, what is third quartile, what is maximum. See, everything is given to you. So you can get all your 5-point summary from stats. So it becomes so much easier. All right. So stats give you 5-point summary. Total, if you want to get total of, like if you want to add them together, so instead of writing 46 plus 56 plus 87, you can just do it like this also. You will get the total. So just adding numbers together, nothing else. And count is just counting the numbers. And mean is just total over count. All right. Spearman, this is for, okay, again, go to the warning sign. Again, you have to give two lists because it is also going to give you rank. List operations, we won't be doing this for now. Sort, as mean you can sort them. For example, if you, again, you write it over here like this. And if you, why is it not sorting it? Okay. And you can copy paste your equations also. So yeah, list I've never used, so I don't know how to do any of that. All right, but you can try. Visualizations, you can visualize your histogram, dot plot, box plot. For example, if you want to write box plot, again, see over here, you have to write your values in square brackets again. So now if you will see, you can see this is your box plot over here. And now to make use of the graph, you can zoom out, you can zoom in, and you can press default viewport. If you're not able to see it, zoom out, zoom out, and then just you can shift by like dragging it, and then you can zoom in again. So let me write few more values because you can see your box plot. And again, you can see if you want to exclude outliers or not. So this is minimum. This is your first quartile. This is your second quartile. Okay, again, this is too big. So yeah, this is third quartile and that is your maximum. And if you say exclude outliers, it will exclude outliers. If you don't say it, for example, if I have a very big value, and if I say, so it's going up to that value, right? If I say exclude outliers, you can see it stops right over here at 89. All right. So you can create your box plot. If you want to hide it, just click on here. If you want to see it, you can click here. Just click on the plus sign, because over from here also it was getting difficult. So just click on plus sign. You can see what is happening over here. All right. Again, coming back to functions, you can also make your dot plot. So for dot plot, you just have to write dot plot. And inside parentheses, you have to write your table of values in the square brackets. So it's a combination of maths and computer science, the coding. For example, if I write the values 12, 12, 23, 45, 43, 43, 43, 43, 43. See, it's showing all the values. And you can just click on plus. So it's going to show you perfectly how it is happening. All right. And now similarly for histogram, let's see what we have to do. So also it is not necessary that you have to do everything in one. You can also go to 2, 3. For example, now I'll be using 2. So here if you see, this is your histogram, and again, you just have to give the values. 10, 12, 14, 16, 25, 27, 29. And now I'm going to cancel it. So over here, you have to tell the count, relative, density, left or center. All right, so you have 10, 12, 14, 16, 17, 25, and 19. Now let's say I repeat the value. So its height is going to get doubled. Okay. So this is how you can make the histograms as well. Again, click on it, you can see everything. And you can keep experimenting what each symbol is doing, how we can do it. Now distributions also, this is your statistics. So you can do your normal distribution. You can find CDF also. Okay. So you can provide what is the mean and what is the, for example, 23 is the mean and 67 is the standard deviation. Just click on plus over here, you will see the graph. And if you want to find cumulative probability, it's over here. You can give your minimum value. And let's say going from here to here. So it's also going to give you the CDF values. And this is the area that they're finding the probability for. All right. Similarly, you can do T distribution, Poisson distribution, binomial distribution, uniform distribution. You can calculate PDF, you can calculate CDF. You can calculate inverse CDF, you can calculate random also, okay? So PDF should be coordinate distribution with a number. So I'm going to call this D. So this is just like your coding. So you can do D.PDF 4. So PDF for 4 is this much. 45 is this much. If I write 23, it's this much. All right. So you can find probability density, like probability distribution function for any value. And if you want to calculate CDF, you can also get it. Okay. So you can calculate the CDF and PDF from there. Similarly, you can write inverse CDF. So here also I'll show you how you can use it. You have to give, again, the values. And then you have to give a number. So first is this much, 2 is undefined, 3 is also undefined. So I think you can go from 0 to 1. Okay. Yeah. So that is inverse CDF. You can also figure out it from here. Now you can either do the statistical tests also. So I'll skip that for now. Now for calculus, you can. So this is e to the power 65, I think. Yes. So either you can write e to the power 65 or you can write exp 65. If you write e to the power x, you can see the graph. Okay. Just click on home, you can see the graph. Or you can also write e to the power x. Both are the same thing. So exp just means e to the power. You can write ln for natural logarithm, log for common logarithm. You can write x to get the function. You can write a number to get the value. Log is base 10. So again, you can do the same thing, write x to get the function, or write any value to get the answer. This is log A. So what you can do over here, you can provide the base. For example, I want to find log base to 32. You can do it from here. So you can specify the base and you can specify the number. Okay. Also, what you can do, for example, you can also get the functions from here. This is your graph. So log base A is for anything. And now d over dx, through which you can do your derivative. But the problem is, for example, if I write sine x, it's not going to. It is giving you the function of cosine x. All right. If I write cosine x, you can see it will give me the function of negative sine x. So this is a graph of negative sine x. If I write x squared, it should give me the line because it is 2x. All right. And now how you can do it? So you can make a table over here. At 0, it's 0. At 1, it is 2. At 2, it is 4. Yeah, from any equation now, not just this. If I am writing y is equal to 3x squared plus 7x, you can just go here, create a table, and whatever values you require, you can write them down. So at negative 2, the value is negative 2. At negative 1, it's negative 4. At 0, it is 0. At 1, it is 10. And at 2, it is 26. And you can modify them by your choice also. All right. So you just have to go here and then create the table from any equation. And you can only do this with equations. You can't do this with, what do I say? The inequalities. So from equations, you can get the tables. Okay, you just have to go here and you will see a table button over here. So in derivative, you will not get the function like equation, but you can get the like what it will look like. All right. And for example, if you want to find a particular value, for example, 3x squared plus 7x plus 5. I don't know if this will allow it or not. All right. So you will get the function. And now if you want to find the derivative value at a particular value, just go to the table and let's say you want to find at 7. So it's 49. The derivative value is 49. So this is d over dx works. This is how. Now I have derivative. And again, so how this will work? First you write what is f of x. For example, if I specify f of x is 5x cubed. Now if I write f derivative of x, you can see the function of the derivative. Okay. And if you want to see the values, you can create a table of the derivative. You can create a table of the normal function. And if you want to find out double derivative, let's say if this will work or not. Yes. So you can find double derivative graph also. All right. And the normal graph is gone, derivative is gone, double derivative is gone. If you want to see, you can always do it like this. Okay. So that is a function of this derivative, and not just one derivative. You can find as many derivatives as you want. For example, you can also do f triple derivative of x. It's a value because it's constant, it's 30. And if you will do one more time, you will get 0. It doesn't matter how many times you do it, you will get a 0. So this is very useful when you're doing your Taylor polynomials, and calculator is allowed for those questions. So that was about d over dx and f derivative. So f derivative is important because as you increase the numbers, you get single derivative, double derivative, triple derivative. You can get as many derivatives as you want. Now integration. The only problem in integration is you cannot get the function. It should have lower and upper bounds. That means you can only do definite integrals over here. And you can do any kind of integration. After writing, you come to this side by pressing your left arrow key. I mean right arrow key because it's the right side. And you write sin x dx. If it's something else, for example, x cubed plus sin x dx. So now you cannot write dx just like that. You have to first put everything inside parentheses. Okay. And whenever it's showing gray, no need to complete it. So this is the derivative, sorry, integral from 0 to 1. So you can do definite integrals from here. And what if you do not want to go to functions? You can just write int for integral. Okay. Derivative writing doesn't make any sense. So you can just write d over dx. I think it will make sense. All right. Yeah, so that is how you can do integration. And now for a series, you'll have to do sum. So you can also do summation. So in summation also, you have to give the initial value and you have to give the final value. All right. Now, one important thing is in your series, it will be given from 1 to infinity. So can you go up to infinity? And just keep pressing arrows. So if you type infinity, it's not possible because your value should be a finite number. So how do you see if it's converging or diverging? Just type random numbers, 10, 100. So it keeps increasing. That means it's a converging series. Now what will happen if it's, it's a diverging series because it keeps on expanding. For example, over here, it doesn't matter what you do. it's getting fixed at 1.6449. So the sum is going to be 1.6449 and it's your conversion. Okay. So start from 10 and just keep increasing the zeros. You will know whether it's converging or diverging. If the number stops changing after a point, it's converging. So this is for summation. You can add the values. Pi is like that symbol that looks like pi. It's for product. For example, you're trying to find the factorial. So we'll just write n over here. You can see the 5 factorial is 120. Obviously, you can always do it like this, 5 factorial. You can still get it. But yeah, so you can use it for product series. So that's about calculus, and now hyperbolic functions is not in this like in the scope. So I'll not talk about it. One thing, if you forget the midpoint formula, you just have to write the 2 points. This is first point, comma, write the second point. Label it, press home if you can't see it. 2.5 comma 4 is your midpoint. All right. So you can just write midpoint, and in parentheses you have to write the first point, comma, the second point, and you will get your midpoint. Of course, if you remember the formula, you can do it, but you can do it like this. And if for distance, instead of midpoint, you just write distance. So you can see what is the distance between these 2 points. All right, if you forget the formula, and now let's apply the formula. We're taking square root, parentheses 3 minus 2 whole squared plus 5 minus 3 whole squared. It's the same thing. And now you will be wondering why I'm not getting any conversion from decimal to fraction over here, because it's an irrational number. An irrational number cannot be written in the form of P over Q. So that is why you're not seeing it over here. All right. So if you forget the formula, you can directly get the distance from here. So this is sort of geometry. Polygon. So in polygon, you just have to give the points and it will make the polygon for you over here. For example, if vertices of the triangle are given to you, okay, I think I'll change the points. Yeah. So you can see we are able to form a triangle. And if there are 4 points, you can form your quadrilateral also. So it's looking something like this. So you can see the polygon for yourself. 3 points will form a triangle, 2 points will form a line, 4 points will form a quadrilateral, and sort of like that. Custom colors, you don't need it. Sound, you don't need it. Number theory is very important. So for example, if you have to get LCM of any numbers, you can type it in over here. This is giving you LCM. For highest common factor, it is known as greatest common factor as well. You just have to write GCF. You can also see the GCF. Okay. So you can figure out the LCM and GCF also. It's GCD actually. So GCD, GCF, I think is the same thing. Yes, so GCD you can also write, or you can write GCF as well. It's the same thing. But I don't think you can write HCF. Yeah. So greatest common factor, greatest common divisor, you can type anything. So you can calculate your LCM and GCD also from here. Okay. It's lower again. It's showing something. Yeah. All right. So audio bitrate is saying it's slower, but I've never been able to understand it. So I'll leave it for now. And then you can find the mod. So let's say what mod does. So again, you have to give the two values. So it gives you a remainder. For example, if I type 32 divided comma 2, you can see it's 0. 32 comma 3, remainder is 3. 32 comma 4, it's 0 again. 5, it's 2 because remainder. So mod gives you the remainder. So if you want to find out remainder of any division, you can just use mod. Next is ceil. So what will ceil do? It will always round up. Even if you write 23.2, it's 24. 23.1 is also 24. So it will always give you a number above. Floor will just get rid of the decimal point. Okay, but if you actually want to round, you have to use round. For example, here if you write 23.2, it's 23. If you write 23.7, it's 24. If you write 23.5, it's 24. Got it? So ceil, floor are not that important. So you need round. And now let's say what sign does. Okay, what do you want? 4. Negative 4, it's negative. So it's just showing you whether the number is positive or negative. For positive, it will give you 1. For negative, it will give you negative 1. And for example, if you want to find out sign for any function, that's where it becomes important. See over here, greater than 0, it's positive. Less than 0, it's negative. At 0, it's 0. Okay? So you can find the sign chart for any function, where it's positive, where it's negative. For example, if you want for x squared plus 7x plus 6, you can see it's positive from negative infinity to negative 6, negative from negative 6 to this value is negative 1, and it's again positive from negative 1 onwards. And zeros are negative 6 and negative 1. So it can give you the sign chart. This is very useful for AP pre-calc students. If you're inequalities, your polynomial inequalities or rational inequalities, you need this the sign chart for those. You can directly do it if it's a calculated question. If it's not, then you'll have to do it manually. And for SAT students, this type of question never comes. But yes, if such a question comes, you can figure out a sign where it's positive, where it's negative. For positive, it will give you 1. For negative, it will give you negative 1. All right. So this is very useful for AP pre-calc students or even AP calculus students if you're dealing with polynomial or rational inequalities. For example, if I write a rational function, you can see it's like this. From negative 6 to this value, negative 3, it's positive. Negative 3 to negative 1, it's negative. And from negative 1 onwards, it's positive again. And not just polynomial or rational, you can write sin x also. See, positive, negative, it's showing you everything. So that's very important if you want to make the sign chart, and it's very important for your inequalities. So greater than 0, you can see where it's greater than 0. Less than 0, you can see where it's less than 0. Now for square root, we have seen there's a symbol over here. But what for if you want to find out cube roots, fourth root or anything, you just write this symbol. For example, if you want to find cube root, you can also write a function. You can get the function. Or if you want to find cube root of, let's say, 27, you can get your answer as well. All right. How you can do it without going to functions, just type nth root. So nth root. I'm showing it again. nth root. It will become this symbol. And you can find any thing. Let's see. So you can get the functions also, you can get the values also. All right. And here again, you're not seeing any conversion because it's an irrational number. Now you can do your NPR. This is for factorial. So you have to give the value of n and you have to give the value of r. You will directly get your answer. For example, if you have to write 4p3, so you just write NPR and then you give 4, 3. You will get your answer. So NPR is for arrangements. It was covered in algebra. In some schools it is covered in algebra 2. In some schools it is It used to be covered in pre-calc, but alas, pre-calc is not having any combination now. So the only possibility is where the schools cover it in Algebra 2. Similarly, NCR, this is for your combinations. Again, if you want to find 3C2, C3 comma 2, you can get the value. So the first argument is the value of n, the second argument is the value of r. You cannot give a value greater than over here. For example, you can get your answers from here. So this is your NPR and NCR. So these are all the functions that you can do. Number theory, sound and custom colors, we're not seeing. Geometry, you can find distance and midpoint. Hyperbolic functions, we're not covering. In calculus, you can find the definite integrals, the summation of the series, and through the series, you can see whether it's converging or diverging. Of course, you cannot write infinity, but you can just keep increasing the numbers 10, 100, 1000, 10,000, so forth. You can find any derivative. You just have to write f of x, the function, then f derivative of x, f double derivative of x, f triple derivative of x. You can get the graphs. D over dx will just give you one derivative. Log base a, any log, any base. This is the common logarithm, this is natural logarithm, and this is e to the power. Statistical test we have not covered, but distributions we have seen, visualizations we have seen. This is all statistics. List operations we have not covered. Statistics, you can find all these things, and these are inverse trigonometric and trigonometric functions. All right. And this is your less than, greater than or equal to, greater than, less than, these things. And if you want to type any other symbols, you can do it from here. For example, theta is also here. So you can go to ABC and see theta over there, or you can just type theta. THETA. This symbol is known as theta. So if you write theta, you can see theta over here. All right. Now we'll see the graph settings. In graph settings, if you want to make it bigger, you can make it bigger. If you want to make it smaller, you can make it smaller. If you want black, you can do it. If you want braille mode, you can just do it. Okay. Now, if you don't want the grids, you can get rid of them. If you don't want excess numbers, you can get rid of them. If you don't want minor grids, you can get rid of them as well. So this is all what you can do. If you want to see arrows, you can put arrows. If you don't want, you can just, or if you just want arrows on one side, you can do that as well. All right. Now this is your rectangular coordinate system. This is very useful for AB pre-calc and calculus students. This is not for SAT. This is your polar coordinate. So for example, your equation r is equal to 3 cosine theta. You can see this is the graph. All right. And also sometimes the questions is from 0 to 1. It's just this portion. All right. So you can also see the portions. And if you write 0 to pi, it's the entire circle. 2 pi is also the entire circle. All right. So pi over 2 is your half circle. So this is your, the only problem is you cannot, for example, if you type any point 3 comma pi over 2, 3 comma pi over 2, this is not in polar coordinates, this is only in rectangular coordinates. So that's a problem because you're not on the radius 3 and angle pi over 2. So for that, you will have to write 3 cosine pi over 2 and 3 sine pi over 2. Now it's over there. All right. So yeah, this is for AP pre-calc and AP calculus. For SAT, we are never using polar coordinates, so it doesn't matter. For example, yeah, in SAT, if you get question like 10, 3 pi over 4, you just type it over here, you'll get your answer. Okay, so in parentheses, you just write the angle and your job will be done. Now you can see in x-axis, you're going from negative to 10 to 10. If you want to increase it, you can go from negative 100 to 100. It's your choice which values you want to see. And you can also change the step. For example, if it's a sine function, you want to have pi over 8 or pi over 4 as your period. like your step, then you can do it. And you're going from negative 2 pi to 2 pi. So here each step is of pi over 8. In the middle, you will see pi over 4. Okay? So pi over 8. This is pi over 3 and like that. Yeah, see. Now you have pi over 8, pi over 4, 3, pi over 8, pi over 2. So you can change your x coordinates to whatever you want. Similarly, you can do it for y label. For example, sometimes it is in hundreds. So you can directly go from 1200s to 1600s. And you can make a step of 100 or 10, whatever you want. Okay? So more options. Because sometimes what you do, if you just keep pressing the zoom out button, the negative sign over there, the graph becomes very small. So if you want your data in this, you can just change the y-axis values also. So you can have linear. This is useful for pre-calc students. You can have logarithmic scale. In semi-log, your y-axis is on logarithmic, x-axis is normal. So you can also do that. You can lock viewport as well. And then you won't be able to do anything. You won't be able to zoom out, zoom in or anything. If you remove, then you can do everything with it. Complex mode, it's over there. All right. Now, if you remove complex mode, remember, radians means your angle is in radians, degrees means your angle is in degrees. For example, if you have to find the value of sine 60 degree. So when you're writing 60, you have to make sure that here you have selected degrees. You have not selected radians, because if you have selected radians, you will get a different answer. And for example, if you're finding the value of sine 7 pi over 5. Now you have to make sure that it should be in radians, not in degrees. So always check your angles. And this is your semi-logarithmic scale. X-axis is in linear, y-axis is logarithmic. All right. And for example, if you have very big y values in thousands or hundreds, you can just change your inputs from here. Okay. Yeah. So that was the introduction. I hope it was helpful. So we have seen how we can do regression normally, and now, for example, one more thing is remaining: how to solve equations and inequalities. So for example, you have y is equal to 3x, not y is equal to, let's say you have 3x plus 5 is equal to 7x plus 9. Press home. Let's make it linear and linear. Yeah. You can see the answer is -1. So this is the x, because if we're finding the value of x, so we're looking for the x value, it's -1. So the value of x is -1 over here. Now for linear and quadratic equations, you can directly write the equation. For example, you can also write x squared plus 7x plus 9 is equal to 3x squared plus 4x plus 5. Still, you'll get your answers. Okay. And remember, all these can be your irrational numbers also, or repeating decimals also. All right. So negative 0.85078 and 2.35078. These two are your answers. For x, you'll be getting your lines, and you just have to look at the x coordinate. All right. But now if you go for, and here I'll remove the step. And here also I'll remove the step. So it's good now. So, and Desmos does not understand anything other than y and x. For example, if you write p plus 5 is equal to p plus 3, it will not understand it. So change every variable to x. Let's say if you have a cubic equation. See, there's only one answer, but if when you click on it, you cannot see the value. So you'll have to do And it's going to be difficult because you still cannot see value, you can only see approximation. So for that, what you do, you write the equation and then you write y is equal to 0. Now look at the point of intersection. This is your answer, negative 0.62582. It could be y is equal to 7 also. Then again, look for point of intersection, that is your answer. And because we want to find the value of x, we're finding the value of x. And it could be any equation also, for example, x plus 2. Now you're finding point of intersection of these two graphs. All right. For anything other than your linear and quadratic, right, left side on number 1, right side on number 2 of equal to. All right. And if it's a number, always write y is equal to. For example, if you just write 7, it doesn't make any sense. So always write y is equal to. So this is how we can solve equations. And for inequalities, see, you can see it's going everything away from negative 7. So here you can see from negative 7 you're going to the left, from 0 you're going to the right. So you can also solve your inequalities like this. So now in cubic you cannot see the numbers. Okay. So now you see the point of intersection, it's negative 0.67. So you're going above negative 0.67. All right. If it's greater than it, you do not know this value. So do not write it over here. Just write y is greater than 8 over here. Zoom out. See the point of intersection. So you're going to the right from 0.41813. Okay. So do it like that. You can also make it equal to. For equal to, dots will be given, gone, it will be solid lines. You can also do less than. You can also do less than or equal to. Only thing is if it's something else, for example, if it's a logarithmic equation also, see, you're getting the values, but you're not able to point on them. So how do you do it? In the next line, you make y is equal to 8. And now you look, negative 58.1, 51.15. These are your two answers. All right. For rational functions, logarithmic functions, exponential functions, also you do the same thing. So that's how you can do your equations and inequalities. And one more thing, for example, you can also store your calculations in variables. For example, if I do a is equal to 23 plus 56, and I have to do 23 plus 56 divided by something. So instead of writing 79, I can just do a divided by 8. I'll still get my answer. And this I can convert back, 79 over 8. All right, so you can store in variables also. And now there's something known as slider. For example, you have a x squared plus 5x plus 6. So you can add a slider and you can change the values. So this is very helpful when you have to figure out a parameter in SAT questions and your options are given. So you can just type your options. What is happening at 9? What is happening at 7? What is happening at 5? And what is happening at 0? Not 0, 1. So where it is going to have two solutions at 1. Okay. I don't recommend it when it's a free response question, because then it could be like 14.62534. We will not be able to get that precise answer, or it could be in hundreds also. So I won't recommend doing it. Okay. So you can also keep it in animation mode and you can see your options, but you can always add sliders. So I recommend it when the options are already given to you. So we have seen how to add sliders, how to do regression. Again, you make the table. Yeah, these are your points. And now, if you want to do your normal regressions, you can do them. You can also see your points like this. You can also see your points like these. If you want lines, you can see also a line. Okay. If you want to drag the points, you can also drag them. And you can also do undo if you have done something wrong. So undo and redo option is also present. So double click on it. You don't want to drag it. And you just add regression. For linear regression, it's 4x plus 38.33. And if you want to export as custom regression, you can do this as well. All right, your slope is 4. This is 38.33. If you're doing quadratic regression, then this is 2x squared minus 40x plus 45. All right. And now using this equation, for example, if you have to find the x value when y is equal to 78, you can do it. Zoom out, you will see these values. So you can see the x values also. Or for example, if x value is given to you, for example, you have to find what is happening at 10 seconds. So you can just write x is equal to 10. Yeah. See this gray dot? This is 10, 205. All right. So now you can also do, and Desmos modeling you can always do whenever you have to find the equation, whenever points are given to you. Or not points. If slope and a point was also given to you, then also you can use it. For that, you'll have to use custom regression because you already know what is your slope. Okay. Now you can also make your circles, parabolas, hyperbolas, and all those things. Press home. Now, if you want to figure out what is the diameter, see this is the maximum point, this is the minimum point. You can take this point, you can take this point. You can call this point A. You can call this point B. And then if you want to find the center, you can write midpoint A, comma B. You can see this is the center. Or if you want to find the radius, you can find distance. And then divided by 2, that is your radius. Over here you can directly see, but if it's an equation like this. Yeah. So now again, always look for diameter on the y-axis. Will give you the endpoints over there. Never look over here. So you take this point over here. You can see a gray dot. Take this point over here. Gray dots are very useful. And now we'll do the same thing. I will call this A. Because it's easy. Give them names. Otherwise it'll get difficult, right? You cannot type negative 1.25 in like that. And now if you want to find the center, you can just do it like this. And label so you can see the points. Negative 1.25, negative 1.75 is your midpoint. And if you want to find the radius, find the diameter by writing this and then divide by 2. This is your radius. All right. Yeah, so that is it. I think I'll stop now. I've tried to cover everything, give an overview of Desmos, how you can do things over there. And I hope it is helpful. And in more detail, we can do later, like for example, doing questions. You have seen me doing questions. And you can do one more thing. It's about the percentages. So for percentage questions, how you can solve them? Let's say you have to find the percentage x% of. So whenever you type percent sign, off automatically comes. 6 is equal to 9. 150% of 6 is 9. So you will get the value. For example, percentage is given. You have to find 25% of 6. Again, you can get the answer. 25% of 6 is 1.5. For example, 25% of x you have to find, because there's only 3 things that you have to find. Again, you can see it's 28. 25% of 28 is 7. So percentage equations, if percentage is not given, just write x over here. If whole is not given, write x here. If you want to find the part, write x over here. And this is how you can solve all your percentage questions. It's very, very easy. For example, if you have to do double percentage, like 25% of 7% of 9, it'll also give you the value, and you can also convert it into a fraction. So that was about percentages. It is very useful in your SAT exams. Yeah. So that was the overview, how you can use Desmos, for what things you can use Desmos. You can do anything and everything with Desmos. Okay. Yeah, so that is it. We're done here. And for specific questions, I've been using in questions, but I've just told you how you yourself can find out how to use Desmos. All right. So from equations, you can get the tables, and then from tables, you can make the equations, or from points or some parameters, you can figure out the equations using regression. And then, yeah, you can find distance, midpoint, and you can use it in circles. You can use it everywhere else. And then you can do statistics. You can find mean, median without actually knowing the formulas or without actually going through the manual process. You can also find standard deviation and all those things. And you can also do your differentiation, where you can see your differentiation graphs. And then you can do your definite integrals. And you can also like see polar curves and polar coordinates over here. Yeah. So that is it. We're done for today. I'll do the next slide somewhat later. So this was just how you can handle Desmos. So yeah, and how we can solve equations, how we can solve inequalities. We have seen everything. Okay. So bye.